Hi there, this is Penelope. This is the fourth video in a series of short videos for PLC 2. And here we're looking at 4 to 20 milliamp loops. Now I know you don't write milliamps with a capital M, but I couldn't make it do a little m. So this is the dominant type of analog signal used in process control, and it's based on fundamental principles like Ohm's law, where the current is constant in a loop. And it's got some characteristics that we'll look at. It's very well standardized. So that 4 milliamps means 0% output and 20 milliamps means 100% output. So it's easy to detect issues. It's the simplest to configure and connect. It's cheaper to run than any other solution because it's got less wires or fewer wires and connections than other signal systems. It's got high resistance to noise and electrical disturbances. It's great for long distances. Because it doesn't, as the current doesn't degrade over long connections. It can only transmit one signal at a time. And multiple loops require special isolation of each loop. And obviously the higher number of loops, the more complicated are the isolation requirements. Let's have a look at a picture. Again, that says milliamps. Right, you've got a sensor, and the sensor measures a process variable. Then the transmitter converts that sensor's measurement into a current signal. Then you have a power source that supplies some voltage. You have a loop, which is a wire connecting the sensor to the device receiving the 4 to 20 milliamp signal and then back to the transmitter. Then there's a receiver which receives, obviously, and interprets the current signal, and there we have it. Okay, that's that.